Hey everybody, it's John with Freshwater Systems. In today's video, I want to talk about PFAS. PFAS is a group of chemicals that's really lit up our industry and is one of the leading contaminant concerns we have today. PFAS is an acronym for pre- or polyfluoroalkyl substances. Not easy to say, but it's been talked about a lot. If you Google PFAS, you will find hundreds, if not thousands, of articles and YouTube videos of all kinds of information. Some of it is really good. Some of it is people just talking. Who's to blame? How do we put them in jail and all that fun stuff? My goal for this video is to give you some options and steps to take to get PFAS out of your drinking water. So a basic review of the PFAS story is it's a man-made compound, a group of chemicals invented in the 40s and used extensively in things like Teflon cookware, water and stain repellents, cosmetics, firefighting foam. The list goes on and on and on. Food packaging. They are everywhere. They're in our environment and they're in us. The PFAS group consists of somewhere between 9 and possibly 14,000 different configurations. We still don't know exactly how many of these chemicals are in our environment. And these compounds are being found everywhere they're looked for. In the environment, they're found in Antarctica, in our human bodies. Everybody that's had a blood test for PFAS has shown positive. So these compounds have been around so long, they have affected all of us. And the fact that they don't degrade, that's part of the problem. Scientific studies have shown that exposure to PFAS can cause health-related problems for humans and for animals. So how do these PFAS chemicals get into our environment? Well, there's runoff from landfills, industrial places where PFAS is made, military bases and airports where the firefighting foams are used quite a bit, and farmland, agriculture, where biosolids are used as fertilizer. Biosolids are sewage, treated sewage. Think manure. These biosolids, if they're containing PFAS, that means that even in our produce and vegetables are having levels of PFAS. So here's the deal. PFAS is everywhere, and it's becoming so widespread. How do you know if it's in your drinking water or not? Well, the answer to that is have it tested. If you're on city water, contact your municipality. I'm pretty sure most municipalities today, even though the EPA is a little behind on regulatory, and I'll talk to that in a second, have a way to test for PFAS. If you live on a well and if you have a private well, then you need to find a laboratory that will be able to test for PFAS. And there will be a link at the end of the video that will give you that information. Bottom line, from a regulatory standpoint, the EPA has not come up with a maximum contaminant level for PFAS chemicals as of yet. There's so many of them and there's so many things to figure out. The EPA has listed a health advisory. A health advisory, the level is 4 parts per trillion. That's amazing to me. We're used to dealing with parts per million or parts per billion. Well, even finer yet is parts per trillion. Let me give you an analogy to help kind of visualize what that means. If you had 1 trillion beach balls, it only takes 4 of them to cause you a health issue. That's not very many. Hopefully the EPA is going to come up with a maximum contaminant level that's an enforceable rule for all water suppliers within the next 12 months. Okay, so what can you do to filter out PFAS? Fortunately, the answer is not that complex. The one product that will take PFAS out very effectively is granulated activated carbon. This can be available in a variety of things. A whole house application, a point of entry application, could be a cubic foot backwashing type carbon. It could be, if you're on city water, it could be an upflow type carbon-based filter. There's a lot of varieties. I'm going to show some links at the end of this video of point of entry type carbon filters. Another technology that's very effective is reverse osmosis. Reverse osmosis is more of a point of use application, treating all the water you're going to drink and cook with in the kitchen. So it works really well. And an option for you with that, if you put RO in your point of use in the kitchen, you might consider putting carbon filters in the bathrooms so that the water you use to take pills or brush your teeth has been treated with a carbon filtration, very effective. And finally, the last technology that is effective at PFAS reduction is ion exchange, but not like a water softener. Ion exchange that uses anion resin. The resins have a chemical charge, and PFAS is positively charged, so anion resin, which is negative, is the only thing that's going to grab a hold of them. The problem with ion exchange PFAS reduction is other positively charged ions will also get captured. So based upon what's in your water, the capacity of these resins can be very limited. And I would suggest you're only going to want to use those as a point of use solution, not point of entry. They're very expensive, and it's really one use. You cannot regenerate these easily and effectively. So point of use for the anion ion exchange is about the only way that I would recommend you use those. My final thoughts are: be sure whether or not you're at risk. Have your water tested. Reach out to your municipality. If you're on a private well, have your water tested. Be sure that you've taken the steps to protect yourself and your family. In the links below, we've listed EPA recommended laboratories. We've also listed the products that we recommend for getting rid of PFAS. So be sure and check those out. If you have any questions, give us a call. Be sure and like and subscribe. And until next time, see you later.